Okay, is there anything written in a tag? Okay, let's continue. This is the class name and this is my object. This is the difference between the class and object. Okay, object is an instance of class. Shortly, this is it. Okay. How am I defining my class? You are just giving class and writing any class name. And you can give your instance names here, similar to here. For example, my circle AB all belongs to circle type. Also, instead of here, you can give the instance names just similar to saying that int my circle, int A, int B. This is very similar to it. You are giving the class name and defining your variables. Also, you have access modifiers. You have 3 access modifiers, which are private, public, and protected. Actually, you do not have to say private here because anything you give in the class definition automatically, defaultly becomes private, okay? You do not have to say that, but if you want, you can say. That's not important. But if you want to define something public or protected, then you have to define it. Like here. Public means I can reach those things from anywhere else. Where is it? Okay. From anywhere else. From main, from other functions, from other instances of other classes. But if it is private, you can only reach from the instance of that class, okay? I can only reach from instance of circle to these things. I have also protected, but I will explain it later because it's about inheritance. So we will talk about it later. Also, I will talk about the friendship later, but you can know just right now about think that you can reach the private members of a class from the friend classes also. Both from the members of that class and from the friend classes. And we will repeat them later. Also, I think you already know this operator. This means that I'm defining a function or a variable belonging to that class. That means this operator means belonging. So for example, I'm giving some function declaration here. This is the function declaration. I'm not defining my function yet. I'm just saying that I have such a function, but I don't know the content of the function. And later, after finishing my class definition, I want to define this function. What will it do? Now I'm giving my function definition here. I'm saying that I'm defining a function named setRadius, which belongs to circle class. If you define your function without putting these things, sometimes you may forget. If you just define it in this way, then when you try to call setRadius function of a circle instance, then your compiler will give an error. It will say that you are calling the setRadius of circle, but I cannot see its definition. There does not exist any setRadius function. And you will look at what does the compiler say? I'm seeing setRadius function just here. But the thing that you miss is compiler sees a normal setRadius function. It doesn't understand this function belongs to this class. So this definition and this definition is different, okay? This is a normal definition, and this says this will only valid for the circle instances. Okay. Also, I guess you already know these differences, dot operator and arrow operator. Dot operator is used for the object itself, not from the pointer. Okay, I'm reaching the object itself just from its name. But arrow operator says that I'm trying to reach my variable from its pointer. Namely, let's see the example. I'm defining a circle variable here, and I'm calling its function, set radius function. I'm using dot operator because I'm using the object itself. But here I'm defining a pointer. I'm allocating new space for that variable. And this time, while I call my set radius function, I use arrow operator because the D was a pointer. Later on, I'm deleting D, and that's it. So the important things comes up to here. Do you have any question? If you do not have, let's talk about the more important things. Constructors and destructors. Actually, these are spatial functions belonging to the classes. And these are defaultly defined by the class, actually. By any class give you this constructor and destructor functions defaultly, okay? But sometimes you may need to define them by yourself. So when do we need to define them by ourselves? For example, if you need to allocate some space or if you need to initialize your variable with some values, then you may need your own constructor. And if you want to, if you have to allocate some dynamic memory and while finishing your job with that variable, you have to deallocate that space. Then you may need to define your own destructor, which deallocates the space that you allocated in the constructor or in any function of the class, okay? What do I mean with dynamic allocation? This is important. Actual dynamic allocation is the spaces that you obtain by new keywords or malloc, calloc, realloc, this kind of things. Or, this kind of things. This is dynamic allocation, and this means that the control totally belongs to you. Namely, you allocated it yourself, so you have to deallocate it by yourself. Okay, the compiler doesn't get involved into it. But if it is not dynamic allocation, if your variable is not dynamically allocated, then compiler will automatically deallocate. So let's see some examples. For example, very basic variable int degree. This is actually not the dynamic deallocation. Okay, this is very basic int variable. So since this is not a dynamic allocation, this will reside in heap. This will reside in stack memory. Okay, we have two things: stack and heap. If you allocate some space, they will live in heap memory. But if you do not allocate space, like in degree, then they will live in stack memory. Okay. So double quefs. Okay, this is a pointer. Now, in the constructor, I'm taking some space for this pointer with new keywords. Okay, I'm taking one double for quefs. Now, the control belongs to me. As I allocated it, I have to deallocate it somewhere. Depending on my implementation, I can deallocate it anywhere, but generally, we deallocate those things in the destructors, okay? So how do I deallocate? Actually, I'm calling the delete operator here. So let's see the constructor properties. Constructor and destructors actually will actually have the same name with the class itself. As you see, polynomial is my class, and this is my constructor. Destructor has also the same name, but it has such kind of tilde operator at the beginning of his name. So, okay, these are the default definition, default type of constructor and destructor. But since I wrote some different things inside it, these are not default anymore, okay? I can define many constructors, actually. I can override it. But there should be a difference between those constructors. Each constructor has to have different type of arguments. Like here, I have two constructors. Actually, this is the default constructor because it doesn't do anything. And this is my second constructor. This is a more special constructor because I'm defining my variables. By the way, I'm saying this is default constructor, but actually, since you define it here yourself, this does the same job with the default constructor, but the name of it is not default constructor anymore, okay? But does the same job with the default constructor. So I have two constructors here. Let's read the chat. That totally depends on the, you're asking from the example from the slide, I guess. Yes, you can write such a constructor. Put it to BA first. Yes, I will show those kind of examples also.
Hocam, can you open public chat so that we can see the question as well?
Yes, I can open it publicly. Now I guess it's public. Okay, let's continue. Lastly, I said that we have two constructors here, but as you see, these have different arguments. The first one doesn't have an argument, and the second one has two arguments. They have to have different arguments because if they have the same things, how the compiler understands which one should it call? It will understand from the different types of the arguments. So you have to define them differently, okay? And let's see the second class. This has a constructor. Actually, it allocates some space for the variable 2. This is the stack variable, and this is the heap variable. Because I'm not allocating any space for the variable 1, but I'm allocating some space for the variable 2. And since I allocated some space, I have to delete it somewhere, otherwise it will result in memory leak, okay? I will lose control and this space will float somewhere in the memory, okay? So I have to delete it somewhere, and the most suitable place, according to this short implementation, is deleting it in the destructor, just it. Okay, let's see an example up to here. Okay, you see a polynomial class here. Let's examine the properties of it. It has a constructor, okay. This constructor doesn't have an argument. It has a second constructor which takes an integer variable. Okay, it has the structure. And we will see them later. These are copy constructor and assignment operators. Let's see the definitions. These are function declarations. And now see the definitions. The first constructor is, okay, it just takes some space for the variables and initializes some values. Let's see the second constructor. It also allocates some space, but with respect to the argument that it takes. So it allocates this much space. That's also okay. So let's see the destructor also. It just deallocates the coefficients. So let's see the main. The important thing is here. Okay, it just defines a basic P polynomial. When I define it in this way, do you think that it will call some constructor? What do you think? It will call or it will not call? Let's see the chat. Yes, it will call the default constructor actually. Namely, you are defining in this way, but it calls automatically this one. So it does these operations just at this line, okay? But this polynomial, this second polynomial variable, calls the other constructor because it calls it with an argument, so it will call the other constructor, this one. So it handles this operation. Okay, let's call it. I'm compiling it in this way. I'm saying G++, and I'm creating my object files. Okay, let's change its name. Okay, executable. And I'm I'm calling my classes here, polynomial main, okay. Now it compiled and I'm calling in this way, executable. I'm running in this way. These two things are important for us. It prints this line, first constructor code, and then it prints the second constructor, just because of this line, okay? If I change my definition in this way, let's say char, okay? You can give the argument name here if you wish. It isn't important. I'm not giving. So let's say char A, okay? It doesn't have any job, but let's define it in this way. Let's call it again. Let's compile it again. Did I save it? Yes. So as you see, this gives an error because it wants to call the default constructor, but it says that you do not have any default constructor for the polynomial class. But remember, we said that every class gives you default constructor and default destructor. So what is it? Why does it give an error? Because when you call your own constructors, it will override the default constructor, okay? Even if you write something like that, for example, it does the same job with the default constructor, this one, because it doesn't do anything. It will again, let's change this one, this time, let's say double, for example. Then this time it will give an error again because it wants to call the default constructor, which doesn't have any arguments. So you have to give your own constructor, which is suitable with this call, okay? So if I delete this one, then I will not take an error. Name it, I have to delete these things also. Okay. Oh, what's it? Oh, I forgot to delete this thing too. Let's take commands. As you see, it didn't give an error. Okay, this line causes the error. So after you define your constructor, know that the default constructor has gone, okay? This thing was important. We also need to find the default constructor. You do not have to define the default constructor unless you have such kind of lines, okay? As you see, I took this line into comments and I do not have any default constructor and it works again. It compiled again. So we do not have to define the default constructor always. But if we need, like here, we need it because this call wants to call the constructor something similar to default constructor. If we have such a line, then we have to define such a suitable constructor, okay? We have to have something like, okay, let's delete these things. So did you get it? We do not have to define it always. Okay. Let's continue with the copy constructor. Copy constructor, as you see, it has constructors in its name. Because it also constructs a variable, but differs from the original constructor is that you are constructing your object by copying some other variable. Okay. Let's see is declaration and definition here. This continues from the second box. Okay. It has constructor. Okay. It has destructor. That's also okay. Now this has the copy constructor. As you see, this has also the same name with the class itself, but it takes some arguments here. So difference from the constructor declaration is this, okay? It takes some argument, and that argument is constant polynomial P. I will explain the constants, and also I will explain this AND operator, but for now, just memorize it. Okay, now I understand that this is a copy constructor, and I see that this also constructs an object, but this copy is the P object it takes. This is also another polynomial object, and does the same thing with the P object. Namely, it copies the P degree, it copies the P coefficients, like here. Okay. So actually, you do not have to define a copy constructor, because it is also every class has also have a default copy constructor, but the default copy constructors do shallow copy. There are two copies, shallow copies and deep copies. Let's write here. Let's use this as a board. Shallow copy and deep copy. Default constructors does default copy constructors does the shallow copy. What do I mean? Actually, for example, I have a coefs variable here, and I want to define a copy constructor, or I'm not defining. Let's see what the default copy constructor does. It will have such a thing. Let's copy here. I have two things, degree and coefs. It will do degree is P degree, and the difference is here. It will say that coefs is P coefs. This is the shallow copy. Why? Because I'm not copying the contents of coef pointer. I'm not copying the contents. I'm just saying that whatever P coefs show, whatever it points, I want to point the same thing. Namely, I have a memory space. Let's say memory space X. Okay, I'm using this as a board. So this is not a formal explanation. Okay. This is the memory space X, let's say, and P coefs show here. P dot coefs show this space in the memory. Okay. And when I say that coefs equals to P coefs, then it will show the same place here. Now, my own coefs, you can also say this coefs, this pointer means that my own my pointer to my own object. Okay, let's delete it for now. Okay, these two shows the same place. So you didn't copy the content of the memory space 6. This is a shallow copy. But yani sığ kopyalama Türkçesi. Derin kopyalama ise nasıl oluyor? So let's see the deep copy. You have to allocate some space for the queries. We already have a deep copy here. This is the deep copy. I will see the chat, but in a minute, okay? This is the copy constructor which does the deep copy. So it allocates some space for the queries, and it copies the content of the queries with memcopy function, or you can just call with int i eşittir işte int i equals to 0, i küçüktür queries size, whatever else, okay? Let's see degree plus and queries e equals to p queries. Okay, these two things does the same thing. For loop and memcopy does the same thing actually. So it's not important, but as you see now, I'm copying the content of the memory. I allocated some space first, and then I copied all the content one by one. Now this is the deep copy. Namely, let's see the picture here. This was a shallow copy, and deep copy does this thing. I have memory space 6, okay. My pqf shows this one. Now I'm copying the memory. Let's say x prime. Okay, x star. This has the same contents. These have different names and different places in the memory, but the content is totally the same. Now I'm saying that queries shows this one. Okay. This second thing is deep copy. Now let's see the chat. Okay, let's answer the second question. Before copying the, your friend asks that. Okay. You are not seeing the second question, so I'm reading it. Hala mı public değil? Tamam, şimdi public oldu mu? Tamamdır. Okay, one of the questions was that before copying, your friend asks, should I delete this content, namely delete pqfs? No, because this is not assignment operator. This is copy constructor. So you do not have to delete pqfs, okay? Actually, I advise you to do not do this thing, okay? Because probably that actually depends your implementation, but probably you will take error as somewhere. So do not do this. We will see it in the assignment operator. The other question was that, let's see the question again. Arkadaşınız kopyalamıştı. Okay, the class doesn't have a copy constructor, but have a equality operator. Okay, will it first create the object with default constructor, then shallow copy with equality operator, or would it create a compilation error? Actually, we will see this in the example. We are just coming to this one, but here actually you are not calling the assignment operator. You are calling the copy constructor here, because you are constructing a new object. First of all, this is a new object, and how do you construct it? Actually, you are constructing it by copying some other variable. Okay, so this is not an assignment operator. We will see these examples. You're welcome. Okay, so did you understand the shallow copy and deep copy? This was important. If you understand this thing, let's take comment. Now let's see the assignment operator. Okay, assignment operator is, you are defining in this way. First of all, you are saying operator equals to. You are defining in this way, and your argument is this polynomial and p, and you are returning polynomial and p. Okay, just memorize this structure, and I will explain these things. Now, let's see what does it do. Actually, assignment operator is used when you have already an object. Okay, this is not the first construction. You had constructed your object previously as somewhere else. Now, you want to change the content of your object. You want to change the variables of your object. And you want to do this change by taking from another variable, okay? So, just in here, you can use the assignment operator. For example, I had this pointer. Actually, I constructed my this object at the beginning, okay? This is not the first construction. Now I want to change its content by copying from the p variable. First of all, I have to check these two things are equal, because maybe I wrote something like that. Maybe I wrote a equals to a, p equals p, okay? If I wrote this thing, something like this, then I have to check it first. Okay, this operator is equal to p object. If they are equal, then you do not have to do anything. You can just return the content of this pointer, okay? So I'm returning the content of this. But if they are not equal, then I have to copy. Now, how do I copy? Actually, first of all, I have to delete the content of my current content, okay? Because this was not the first construction, so it already has some values. It may already allocated some space for for example. So in order to prevent the memory leaks, first of all, I have to delete my old contents. I have to delete my old contents. So I'm deleting my clefs of this pointer. Also, since degree was already just an integer, you do not have to delete anything about it. So I'm just assigning my p variable degree, okay? Degree of p variable. And now I have to copy the clefs also. First of all, I'm allocating new space for the clefs, that is new double degree. And then I'm copying from p clefs to clefs. From this to this. How much? Size of double times degree. And then at the end, I'm again returning this pointer. So why did I do such a control here? Let's say I didn't do such a control. I'm just calling it p equals to p. And this is not an error, actually. Okay, this doesn't have any meaning, but you can do such a call. But if you do not do such a control, notice that you are deleting your current content first. So I deleted my p's content, and later on, I'm trying to copy p's content to p, namely, like here. But I deleted it, and after the deleting, I'm trying to copy it. So did you see the contradiction? So for not seeing such a contradiction, for not taking error for such kind of lines, you have to do this check. Burayı anladınız mı arkadaşlar? Is deleting clefs mandatory or not? This is mandatory for not taking memory leak. Okay, but not mandatory for not taking any error from the compiler. Compiler doesn't give an error if you do not delete this line, but it results in the memory leak. Okay, what does memory leak mean? Let's explain this thing actually. You are allocating many space, allocating, and if you do not delete anything of them, your memory gets larger, the memory that you are using. And at some place, when you need to do some other computations, or when you need to have some other allocation, you do not have enough memory because you allocated many space and you didn't reallocate them. And also remember that for conducting some basic mathematical operations, you also, for basic mathematical operations also, you have to use some memory, okay? Not just for allocating. For the basic operations, you also have to use the memory. So if you do not allocate them, after some time, your compiler may start to use that garbage memory. And since that garbage memory has some values coming from your previous operations, your current results and your previous results may may get involved into each other, okay? So this may result in erroneous results. Did you get it? So memory leaks are important, actually very important. In the later courses, especially in your third and fourth class courses, you may really need to reallocate some space because you will have to use so large memory, okay? So earlier you learn, better it is. So this is the assignment operator. Let's see the example. Actually, the example is the same thing. So we already saw it here. Okay, let's see the other examples in a few minutes. These four are canonical forms. Okay, default constructor, default destructor, copy constructor, assignment operator. By the way, assignment operator is already given defaultly, but default version doesn't do deep copy. Default version does shallow copy. So not only doing shallow or deep copy, but also it doesn't delete the previous host variable, so it results in memory leak. If you have dynamic memory usage, then default assignment operator results in memory leaks. So it's better to define your own assignment operator. Okay. So let's see AND operators. Okay, we saw some AND operators. At some places, for example, in copy constructor, we saw an AND operator here. What was its name? Ampersand, I guess. Okay, ampersand operator. Also in assignment operator, we saw it both here and here. So what do they mean? Actually, when I use ampersand operator, this is also called the reference operator. It means that I'm not talking about the copy of the object, but I'm taking the actual instance of the object, okay? Not this copy, just the object itself. I'm talking about the object itself. So when we see ampersand operator in the copy constructor, it says that I'm taking the actual version of the P variable. This is not the copy. Also, similarly in the assignment operator, I'm taking the actual version, the P object itself, okay? Not its copy. And also, sometimes I return AND operator, ampersand operator. What does it mean? I'm returning the object itself, not its copy. So I have to be cautious about the usage of the returned value. Now we will see why do we have to be cautious. We have to take attention. Now let's see an important example. Here, okay, we have two functions, f and g. What they are doing is not important. One of them takes the copy of the object, okay, copy of the P object. The other one doesn't take the copy. It takes the original object. It takes the actual object, okay? Because it has ampersand operator, reference operator here. So in the main function, I have a vector C. I'm pushing two values into C. Okay. Now let's see the first line. Polynomial RC. Here, what does it do? What does it call actually? Which function does it call? Do you have an idea? You can write into the chat also. San Fran says copy constructor. Yes. This line calls the copy constructor. Why? Because this is the first construction of the R object. So it has to call some constructor. But which constructor? The original constructor or copy constructor? Since it uses C variable here. Sorry. This is not copy constructor because the C variable is not polynomial. So this is not the copy constructor. This is the constructor calling. Did you get it? C variable just the argument here. But now this one is copy constructor. Why? First of all, this is the first construction of S object. And I'm using R variable here. And R is a polynomial because we define it in this way. This is a polynomial. Now, this is the copy construction. Okay. Also, let's continue. We have polynomial P. What does it call here? By the way, we are assuming that all the necessary things, we already have all the necessary function declarations, okay? So what does it call? This actually calls the default constructor. So let's continue. Now, what does it call? P equals to S. Do you have an idea? Let's see the chat. Yes. Now it calls assignment operator. Why? Because you previously constructed P. This is not the first construction. And you are using S. You are actually transferring the values of S to the value of P. So this is the assignment operator. Okay. Now, what does it call in that line? San Fran says copy constructor. Anything else? Okay. Any other idea? Maybe assignment operator? Don't you think so? Actually, your friends are right. This is the copy construction. Why it is not assignment operator? Because this is the first time of first construction of Q variable. Okay. So although I'm using equality operator here, this doesn't mean that I'm using the assignment operator call. I'm just copying the values of P to values of Q. And here I'm calling my F function with S variable. Here, S variable is just copied. Why? Because F doesn't have a reference operator. It uses copy. So while using copy, it actually calls copy constructor. Because it creates a new variable. You don't see the background, but it constructs a new variable which has the same content with the S variable, same content with this variable. And after F returns, that new variable that you didn't see in the background is deleted automatically, okay? And you continue from your previous jobs. And here, this time G function is called. And now you are calling it with assignment, same reference operator. Now you are not calling any constructor, copy constructor, whatever else, because you are using the object itself. You are using original P, okay? So do you have any question up to here? I will give a break. Okay, let's give a break. Let's get together at after 8 minutes, okay? Namely 19:15, okay? Okay, the break starts. Okay, I'm just repeating in 1 minute for the recording, okay? We have 4 constant keywords. Inside the function, it means that inside the function argument, it means that I cannot change the value of x inside function 1. And if it is written for the return value of the function, like here, it means that I cannot change the value of the return thing. It is not allowed. And if it is used just in here, it means that I cannot, it says that my function tree doesn't change anything related with the class X. We are assuming that this function belongs to some class named X. So I'm not changing anything, any variable of the X. I'm guaranteeing it. And lastly, this says that my X variable is defined, is initialized for just one time, and I cannot change its value later on. So I'm assigning the return value of function to here. We will also see the examples, but first of all, let's see the constant keyword with pointers. Okay. Here you are seeing a constant pointer, and it is assigned the address of value variable, and I'm changing the value of the value variable. This is okay. This is not something special. But the same thing here, but now I want to change the value of the content of pointer. Now this is problematic. This will give an error. Why? Because I defined my pointer constant, so it means that I cannot change its value. I can initialize it only one time. So I'm initializing it, and from now on, I cannot change this value, okay? This will give an error. Changing value variable is not an error, but changing it from the pointer is an error. But this is not an error. What is it? I'm not changing the content of the pointer, but I'm changing the value addressed by the pointer. So now pointer doesn't address value 1. It addresses to value 2. This is okay. Okay, this constant doesn't mean that my pointer cannot access something else later. Okay, this doesn't mean that. This just means that I cannot change the content of that address later on. Okay. And also I can use this constant keyword here, namely after the pointer declaration and before the variable name. This was at the beginning, but this constant is just between. Now, this means that I can change the content of the address, but I cannot change the address itself, okay? So, this is not okay. Because I'm changing the address, initially it was addressing to value 1, now I want to address it to value 2, but this is an error because this constant is here. But now I can change the content of value 1, okay? Okay, it addresses to value variable. Now I want to change the content by using pointer. For the previous usage of constant keyword, this was an error. Namely here, this was an error, this usage, but with this usage, this is not an error. So please take attention to the place of the constants. Okay. Also, let's see the vectors and let's see some important examples. How does vector work? Actually, vector, C++ vector is means that the vector itself, yani bunu bir kovanın içine bir şeyler dolduruyormuşuz gibi düşünün. You can consider it. We are filling the content of a bucket. Okay. Vector is a bucket here. My bucket is on the stack, but my content of the bucket, namely my elements, are on the heap. Okay. So I'm not using a pointer here. Take attention to that. But if I use pointer here, my bucket, namely my vector, is again on the stack, but my pointer is on the heap, and the elements that are pointed could be anywhere. I don't know. Since my pointers are on the heap, I'm relaxed because the control belongs to me. And if I need to deallocate, if I need to delete them, then I can do it freely. With that usage, it may be problematic depending on the places. Okay. I cannot give a definite example. But this doesn't guarantee because the control of the elements doesn't belong to you. So I advise you to use pointers inside the vector. Okay, the control totally belongs to you. Also, let's see this one. Now the star operator is here. Now vector is not on the stack anymore. They are on the heap, okay? Constant int and int constant. What does it int constant do? Onu istersen en sonda açıklayayım. Çünkü az evvel açıkladım, vakit kaybetmeyelim şimdi de. Tamam. En sonunda ben orayı tekrar edeyim. Okay, I advise you to use this vector usage, okay? By using pointer inside the vector. So let's see some important examples. Okay, let's see again the polynomial examples. Okay, we saw assignment operators. This is, by the way, operator overload, because we already have an assignment operator, but I'm overloading it. I'm reusing, redefining it. Now, okay, I have another function named setPolynomial. It just constructs, it doesn't construct, but it assigns new values to the polynomial, okay? It assigns d to the degree, and it assigns c to the coefs. That is also okay. So let's see this new operator overload, which is the summation operator. I will comment this one. Now let's see this. What does it do, this assignment operator? It will actually sum the value of this pointer and the value of p. Okay. So I'm creating a local variable here, namely this variable, this polynomial is on the stack, not on the heap, because I'm not allocating in space. And then, okay, I'm assigning degree here. And then I'm trying to sum the values. I'm summing one by one. Okay, I'm summating the coefs of this variable and coefs of p. And I'm assigning the result into it. And at the end, I'm returning local p. So, burada şeye takıldım da, local p constructor'dan. Okay, here, since it calls the default constructor, it actually assigns one place, okay, for the coefs. So it doesn't need to allocate any space for the coefs, okay. Don't consider about the size, okay. I'm not trying to give the example about it. I'm trying to show something else here. So you can assume that we have enough size for coef, okay? We have enough size. And I'm returning this local p. But take attention to the returned value of my operator, my function. It returns the reference. But I'm returning a local variable. Actually, local variables, namely the variable i's, die after their jobs are completed. So when my function completes its job, this local variable will die. So how can I return a reference to it? It will die. So it will give an error actually. So let's see the compilation reflection. Here actually, okay, we saw these things. It constructs a polynomial p, and then it calls copy constructor for q, and then it again calls copy constructor for r, and then it assigns, it calls assignment operator and assigns the values of p to values of r. After here, I have to see break one, and then okay, it assign some values to P and some values to Q by set polynomial function. We already saw it. It allocates the enough space and just copies the values. That's also okay. And now we are seeing some summation operator here, P plus Q. It will call this one. Where is it? This one. So let's compile it. This is example 3. Actually, it doesn't give an error, but it gives a warning during the compilation time because of returning local variable. It says that reference to local variable returned. Yani yerel değişkene referans döndün diyor. Bir gariplik var burada diyor. Okay, let's execute it. It gave recitation fault, actually core dump error in the following steps. So actually, this is not safe, okay? This thing is not safe. I cannot return, I shouldn't return a reference to the local variable. By the way, calling of this operator is done in that way, but this is the same thing by calling it in this way. Okay, I'm calling this function of P variable, okay, by using this argument, Q argument. These two lines are the same. You can use in this way also. So it gives an error inside our print function. Let's see the content of the print also. Print just prints the coefficients, content of the coefficients, nothing special. So after break 2, okay, it prints break 2, it says constructor, destructor of this thing. I'm calling constructor, and after returning, I'm calling. The calling person is not me. Compiler automatically calls. Okay, compiler calls destructor here. That is also okay. So constructor called, destructor called. Okay. Now double free or corruption. Why? Also aborted. It doesn't print the content of R also. Okay, did you see the error? Returning reference to a local variable is not safe. It gives an error. It doesn't print the content of the R also. So let's comment this. This is wrong. So let's see another implementation. The different thing is here, I'm using constant arguments. The previous one was also using constant, but here I'm doing something different. I'm assigning the result of this summation to the P itself. But P was constant. So it will give an error. Let's compile it. As you see, this time. The previous one was a runtime error because it just gave a warning during compilation, but it gave an error during the runtime. But this version gives a compilation time error. It says that this is constant and you are changing it. So this is an error. I cannot change value of the P. Now let's see the right implementation. How should I do it? Actually, I have to create a new variable first of all, because I will return a reference at the end. So I'm creating my variable on the heap. And then, okay, I'm just assigning values. Why am I deleting coefficient of the sum? Sum doesn't have any coefficients just now. Because during the constructor, I constructed it here. During the constructor, I allocated some space because of this one, okay? So I'm deleting this allocation and I'm reallocating with new spaces. This is my space. Okay, I'm reallocating and I'm taking the summation and assigning the summation to some variable, and at the end, I'm returning the content of the sum. This is not problematic. I'm returning the content of the sum, and then I want to print the content of that coefficients. Print function prints the content. Okay, let's see. Again, I'm compiling. And I want to execute it. So after the break 2, let's see. After the break 2, okay, constructor called, assignment operator called. And here is the result of the print function, okay, this one. And destructor called. Again, constructor called, again, destructor called up to break 3. Break 3, where is it? Okay, here. Okay, actually, let's put another break here. Do you have an idea why it's called some assignment operator? Break new diyelim. I want to observe the content of between these two breaks, okay? Just content of this thing. Now break new, break 2, okay. This is the content result of the print function, okay? But what are these two things? Constructor called, assignment operator called. These are coming from the these prints, okay? But why does it call assignment operator? Actually, I explained the constructor. There is not constructor operator because since I'm constructing a new object here, it will call constructor. So this is okay. But do you have any idea about it? Yes, but okay, we are assigning it to R. Yes, you are right. But take attention to it returns a reference here. So actually, I shouldn't assign or copy anything because I'm returning reference. I'm directly pushing my variable. So I'm directly saying that, hey, R, please become the result of this thing. Yani kafanızı karıştırmak için soruyorum. What R isn't a reference? Yes. Yes, R isn't a reference. So here actually there occurs some copy operation through the assignment operator, of course. It returns the actual sum variable, okay, but it doesn't assign the actual some variable. It copies the content of some variable to the R through the assignment operator. So this is not distinct, actually. So this results in some, let's say not an error, but some unpleasant thing. Do you have an idea what does it cause? Yani hoş olmayan bir duruma sebebiyet veriyor. Garbage value. Any other idea? Okay, actually yes, garbage value. Why? Yani I mean memory leak. It results in memory leak. Why? Because I copied the result of this operation to this. So what happened to actual object of the result of this operation? What happened to actual object? Namely, what happened to sum? Sum is floating in the memory, so I cannot reach it. But I allocate some space previously, but I cannot reach that space because I lost the control. I lost the ownership, actually. I lost the ownership. But it still continues to allocate some space. So this results in memory leak. I have to use it in a cautious way. Okay? Dikkatli bir şekilde kullanmam lazım. Buradaki memory leak'i anladınız mı arkadaşlar? Bu sum üzerindeki kontrolümü kaybediyorum. Çünkü şuraya kopyasını verdim. Buradan dönen ne oldu? Yani ona bir isim vermedim. Nasıl delete edeceğim? Edemiyorum. O yüzden memory leak olarak kaldı orada. Okay. Let's continue. Let's see the other things. Okay, now I'm again summing E and Q, but this time I'm assigning it in this way. I'm using reference operator. So this time, actually, I already returned the reference and I'm assigning it by using reference operator. So this is the actual object, okay? Not a copy. This doesn't call the assignment operator because this is not copy. This says that, hey, please use my actual object, actual thing that I return. So when I use delete, it will not result in any memory leak. Okay, I can delete this sum. So also let's see deleting this R, what happens. Okay, this part was dangerous. As you see, double tree. I called the destructor, but why does it double tree? Why does it say double tree? Because I'm deleting it. Also, since there is a stack variable, the compiler also automatically tries to delete it. So it is deleted 2 times. So, 2 kere silindiği için, since it was deleted 2 times, it says double tree. Okay. Stack variables are automatically, defaultly deleted by the compiler. So you shouldn't delete it. So this is an error. Also, this is a memory leak. But here I can delete some. This is not an error because I use reference operator, and since I use the reference operator, this is the actual sum variable. and the sum variable control of some variable belongs to me. This is not a stack variable. This is a heap variable. So since I allocated some space, this is a heap variable. I have to deallocate it for not seeing any memory leak. So I'm deleting it. Okay, this is not an error. So let's see. After the break new, okay, it says constructor call, destructor call. This constructor call is because of the inside of the summation operator, because of here. And then, since I'm not using assignment operator, it doesn't say any assignment operator thing here. It just says destructor call because of here. And it says break 3. Okay, did you get it? But still, because of this part, it will give a memory leak. How will I observe the memory leaks? Actually, it is in the slides here. I will use Valgrind. You have to install Valgrind first of all. I already installed it. I will use this line. There is one more dash here, Valgrind. Let's use it. Valgrind. Okay. Let's see. Okay. Well, when I run it by Valgrind, it says there's an error. Because of this error means memory leak. The number says the memory leak also. I have only one memory leak, which is because of this R, okay? Because of the assignment operator, because I lost the control of the actual result of this operation. But if I delete this part, okay, R başka yerde geçmiyor. Okay, I commented it. Now let's see. Let's compile it again. And let's run it by Valgrind again. It says 0 errors, okay? The error was because of this thing, garbage variable. So let's continue. Az bir şey kaldı. P dot get shadow. Okay, let's see the content of the get shadow. It just returns the content of this pointer, but it says that I'm returning in the constant manner. So when I say this in this way, it will give an error because it returns a constant thing, but I'm not assigning it to a constant thing. Let's see the error. As you see, it says this is constant, blah, blah, okay? This returns a constant and I'm assigning it in the reference manner, but this is not constant, so it will give an error. By the way, I can assign it, first of all, okay, it gives an error because of it, but we missed this line. It doesn't give an error in this line. This is also not constant, but why doesn't it give an error? Because this is not a reference assignment. This is the copy operation. This calls the assignment operator. So it just copies the values of the constant variable to Q, okay? It copies. So this is not an error. This calls the assignment operator. Let's see. let's comment it first of all. And let's see. After the break 3, okay, I'm seeing assignment operator called because of here. And this is not an error. And it continues from this part, but when I open this one, it gives an error. So the right thing is, if you want to use the object itself, not the copy, like here, not the if you do not want to use the copy, you want to use the actual object, then you have to put constant keyword here, constant polynomial reference Q3. Okay, you have to use in this way. And okay, this doesn't give an error, but what does it do? Let's see. It doesn't do anything special at this line. It constructs a new variable and then it deletes S because this is heap object and the control belongs to me. I have to delete it and then it prints break 4. Okay, let's see the content again. I didn't save it. Now let's do it again. After break 3, okay, this line doesn't give an error. UP get shadow up to break 4. Okay, assignment operator call, constructor call, destructor call because of here, constructor called, structure called. This doesn't call assignment operator because I assigned the object itself. Okay. So it says constructor called, destructor called, right? Break 4. And then it prints 3 destructor called. Why? I didn't delete anything after the break 4. So what does it delete? It says I deleted 3 things. Actually, I said that for the stack variables, the compiler automatically deletes those objects. So since I have 3 stack variables here, which are P, Q, and R. Okay, these are stack variables. These are automatically deleted by the compiler when my job finishes. So actually, after returning, it deletes those 3 stack variables. Since this is heap, it doesn't delete S. I have to delete S myself. So did you get it? These things? This may seem complex, but actually not. If you get the logic behind, you can see the differences very easily. Is it okay up to here? Now I will continue with the inheritance. Let's give a break. Okay, I will try to finish the inheritance as much quicker as possible. So let's give a 10 minutes break. Okay, let's get together at 20:10. I will talk about the inheritance. Okay, let's continue with the inheritance. Okay. What was the question? Ah. Because the shadow function returns the object itself, not the pointer. Here, where is it? Here, it returns the object itself, not a pointer. For example, this is not something like that. Okay. So I want to reach the content of what this pointer addresses to. And how do I use it? Shadow. These are not pointers too. So if I want to define something like that, for example, polynomials x, let's say, and p dot get shadow. Since this wants to take a pointer, I should return a pointer here. So I can change my definition, and also I'm returning this. Is it okay now? Okay. So let's continue with the inheritance. Okay, you define a class, and then you want to define some other class, but you want to use the features of the previous class. So you are taking totally the same of the previous class, and you are adding the new features to the new class. Here, you can do it in the way that you already know, but this may result in many repeat of the existing code. You are repeating the same code again. And also you are not repeating just only in the class definitions. Later on, you may need to repeat the same things during the function calls or in other operations. So it will, this repeating will bring the new repeatings. So in order to prevent this, in order to do it in a elegant way, you can use inheritance. So for example, I have a class named house, and I want to define two new classes, villa and apartment flats. And these are already a house object. These two has the same features with the house object. And these two also have some new features too. For example, house object has two variables and a function. Now I'm inheriting it. This is the inheritance definition. This means that I'm inheriting house class. I will explain this public, and I will explain protected. I'm inheriting house class, and this means that since I inherited it, I have these properties inside the villa. And also I have a new property. This is the number of flats. Similarly, for the apartment flat, I'm inheriting it from the house. And I have two new variables and a new function. So what does protected mean? Protected is something between the private and public. Private means you cannot reach your object from anywhere else. And protected is also similar to that. You cannot reach protected members from anywhere else, except that the derived classes. Okay, the difference from the private is that if I define them as private, if they were private members, then my villa class could not have these two variables, these two members, if this was private. But I wrote it as protected, so my derived classes can use these variables, but any other class cannot reach those variables, okay? Namely, protected means public to derived classes, private to any other classes, okay? Something between the public and private. Also, I have public here. What does it mean? It means that, okay, I'm inheriting some members from the house, but will these things be protected or public again inside the villa? This defines it. Public means that at least they will be public. So this was already public, and since I'm saying that at least they will be public, okay, this can be again public and this can be again protected. But for example, if I use, let's say, protected here, okay, if I use protected here, then it means that the things that I inherit will be at least protected. Namely, I'm inheriting this function, this is public, but inside villa class, it will be protected because I'm saying at least protected. Protected things can, again, are protected, no problem, and private things are again private. But if I define it as private this time, here if I use private, then this means that at least private. So everything becomes private. These protected things become private, these public things become private, private things again private, okay? Generally, public is used. And if you do a proper implementation, you will not need protected or private here, okay? Any question? Okay.
Hocam, just repeat, you said that protected, if it's protected, nothing changed, but if it's public, protected become public, and if it's private, then everything becomes private. Am I right?
Actually, public doesn't change anything.
Oh, okay.
Public means that at least public, so the default access modifier can be at least public already. So this means everything will automatically be used as it was defined inside house.
Oh,
but if you are using protected here, then only public will change. Public
okay.
Protected.
Okay, thank you.
You're welcome. Let's read here. When you inherit a class, everything is inherited except that the private members, the constructor, the destructor, the friendship is not inherited, and the assignment operator, okay? These things are not inherited, these four things. But, okay, you are not inheriting constructor, destructor, but constructor and destructor automatically called. What do I mean? Okay, let's see from the examples. I think that I'm trying to explain. Here you see mother class and you see two classes that are inheriting from it, daughter and son. So daughter has a constructor itself, but okay, it doesn't call any constructor of the mother, but it automatically, compiler automatically calls the constructor of the mother. Which constructor will it call? Since I didn't specify anything here, it will call the default constructor. So it will call this constructor, this one. Let's see the son. It is also inherited from mother. This is the constructor of son. You see that it calls the constructor of the mother externally, okay? This means that it is calling the related constructor, which is this one, the second one, because it takes an argument here. So the thing that taking argument is the second one. So it calls the second constructor. Namely, both of them calls the constructor, but this son calls externally, but daughter calls internally, okay? But both of them calls the constructor of the mother. Similarly, both of them calls the destructor of the mother. So, okay. Here you see the content of the main. It constructs a daughter object. Okay. And it constructs a son object. When it constructs the daughter object, here you see that it prints mother no parameters, daughter in parameter. It comes from, as I said, daughter calls the default constructor, namely it prints this one, mother no parameters, and then it calls itself. It calls its own constructor, namely daughter in parameter. Okay. Firstly, the base class constructor is called. Then derived class constructor is called. Similarly, it constructs the son object. So son object calls this constructor, which is mother in parameter. It prints it, and then it prints its own constructor content, that is son in parameter. Did you get it? So let's think something here. For example, if I do not define this first mother constructor and assume that I have only the second constructor, this one, I have only this one, I didn't define this one. What happens? The rest is the same. What happens? Do I get error, for example, or what does it print? Do you have an idea? Somebody says we will get a compiler error, the same error when we didn't find the default constructor. And try to create circle. Okay. By the way, there was a question. Yes, it gives an error. Your friends are right, because the author wants to call the default constructor, but there doesn't exist any default constructor. I have only this type of constructor, so it will give an error. Okay, you're right. By the way, there was I saw a question about the previous example. There was a question about here. Your friend asks, if I inherit something new from the villa class this time, your friend asks that what happens to these protected public things. Actually, now you are assuming villa as your base class. So what are these things inside the base class? This is important. For example, since this is public, these are already in their own version inside the Villa class. So the new class inherited from Villa takes the inheritance according to Villa content and according to inheritance type of that new inheritance. Okay? Yani bu iki şeye bağlı. Birincisi Villa'nın içerisinde o şeyler ne halde olacak? Şurada public ya da protected ya da private verdiğinden ötürü Villa'nın içerisinde bunlar ne halde olacak? İkincisi de sen yeni inheritance'ını nasıl yapıyorsun? Public mi, protected mi, private mı? Bu iki şeye bağlı. Okay. I explained it. Also, you can use multiple inheritance. That means you are inheriting from more than one class. You are using, for example, if you are inheriting from two classes, then it means you are using properties from both classes. How do you do it? You are just putting comma to here. Okay, for example, public house, comma, private, let's say car. Anything you want to give. Okay, polymorphism. This is an important feature of C++. Polymorphism means that you are trying to reach a function from other type, okay? But that other type should be something special. For example, it can be base class. I will show an example. For example, here. Okay, I have a new class named virus. Okay, it has protected members, it has public members, constructor, destructor, create RNA function. Let's see it later. Function. And in main function, okay, I'm allocating these two new viruses by calling the constructor and new operator. Okay, this is the pointer variable, blah, blah. Note that, okay, these A and B classes are inherited from the virus class. Okay, this is my virus class. And class A is inherited from virus. Similarly, class B is inherited from virus. And note that I'm allocating space from A and I'm allocating space from B, but I'm assigning them to virus type, not A star virus B, not B star virus B, but I'm using virus type. Now that's the thing, that's the polymorphism, okay? Also, for example, I want to hold the virus vector, like in here. Okay, I'm pushing virus A and virus B into it. And I want to use functions of it. For example, mutate function, print RNA function. Okay, both of them have print RNA function because of here. And I'm calling those functions, mutate and print RNA functions, by using the type of virus star, virus pointer, not because this vector hosts the virus elements, not A star elements or not B star elements. So this is called as the polymorphism. Okay, I can reach the elements of A and B from the base class. And let's continue. What does virtual mean? When do I need it? actually, let's see the print RNA function. Class A doesn't have print RNA function and class B doesn't have print RNA function. Only virus class has print RNA function. And when I call this print RNA function from here, it just calls this one. But let's see the mutate function. Mutate function, assume that you do not you do not have virtual keyword here, okay? Assume that you do not have it. And also don't see the equality 0 part. Assume you have only this thing of mutate. Let's see, it does nothing, for example. But also class A has mutate and class B has mutate. All of them has mutate function, and I want to call mutate function. And if this includes an A object, then I want to call mutate function of A class. If this is a B object, then I want to call mutate function of B class. But when you call it from the virus type, it only calls this mutate function, the mutate function of virus class, not this one, okay? It doesn't call this one. If you want to call the correct mutate functions, then you have to have this virtual keyword. This virtual keyword means that if your object is a pure virus, not A, not B, then it calls this one mutate function of virus class, that's okay. But if your object includes A object, for example, virus 0 is A actually, and virus 1 is virus B actually, the B object. So if your object is A or B, then this thing, when I call the mutate function, it calls the correct mutate functions, namely mutate function of A, mutate function of B, okay? Because I used virtual here. That is the difference. And sometimes I am using sum equal to 0. What does it mean actually here? What do I do? Bottom. Okay. This one. What does it mean? Actually, this means that this means abstraction. Okay, this is abstraction equalizing to 0. And if your class has at least one such function, then your class becomes abstract class. What does abstract class mean? You cannot create an object of that class. You cannot create. For example, I cannot define something like, let's say, a virus X. I cannot define this thing because my class is abstract. My class is an abstract class because of this. If I don't have this thing, okay, that's no problem. I can define this kind of objects. There's no problem. But if it's an abstract class, I cannot define. Okay. Now assume it's an abstract class. I cannot define these things, but I can use pointers. I can use such pointers, okay? Using pointer is no problem, but using the object itself is a problem. Now, abstraction means, okay, I cannot create an object of virus, but I can create object of doll is derived classes, and my mutate function doesn't have any duty, doesn't have any job inside the virus class, but it has only duty in derived classes because of this abstraction. So mutate function in A does something different, okay? It's not important what does it do. And mutate B does some other operation. So, okay, let's leave these things. So when I call these mutate functions, it calls the related mutate functions, and that's it. Anything. That's the thing that I want to mention. Now, when I want to, okay, let's see the question. The virus class abstract because it has a virtual function? No, it's abstract because of equalizing to 0. But you have to use that word together with the virtual keyword because it doesn't have any job itself because of 0. So to give a meaning to it, you have to use virtual for using derived class functions. Okay. Namely, if I remove this part, but virtual stays the same, but I do not have any 0, we call it 0. This is not an abstract class. I can use mutate function. I can use these mutate functions too, thanks to virtual. Just the equalizing to 0 makes it abstraction. Okay. Okay. Okay, one important thing is at the end, I'm deleting my viruses. Okay, I'm calling this delete operator and I'm equalizing them to null. Now, how does this delete works? Actually, let's run it. This is example 4. Let's just have main CPP. Let's see what happens from the beginning. It says abstract base class constructor called and then is constructor called. It actually belongs to this line. This 2 line belongs to this part because when I'm creating my A object, it first hosts the base class constructor, namely this one, base class constructor, and then it runs its own constructor, namely this one, A's constructor call. Okay. Similarly, these 2 lines belong to this one, virus B. And then I'm again creating a new object pointer, this 2 lines belonging to this one, okay? And then I'm deleting pointers. Let's see it. I'm deleting an A object actually, but I'm deleting an A object, but it calls abstract base class destructor calls, namely base class destructor calls. And it doesn't say anything about the A destructor code. it only says base class destructor code. Because I'm deleting it from a pointer variable. Now, okay, these two things come from the print RNA function actually. They are not important. Let's continue. Again, I'm deleting my viruses. Again, you see only the base class destructor code. Okay, it has two objects, so it calls 2 times base class constructor. And now it prints this line. It is just in here. Is there anything special about this one? Now, again, I'm creating a new virus type of A, but I'm assigning to type of A pointer, and now I'm deleting it. This time, you see that, okay, these are coming from the constructor, but this time you see 2 lines of destruction. First of all, it says that A's destructor code, because this is of type A, and then it says that abstract base class destructor code. Did you see the difference? This prints 2 lines of, this delete prints 2 lines of destruction, but the above deletes, this ones and this one, prints only 1 line of destruction, and that is abstract class. It doesn't belong to destruction of A or B. Because of the how the style of your pointing, okay? How you are pointing down. If you point down with the base class pointer, it calls only the base class destructor. Hocam normally, okay, there's a question. Because this is not a static array, this is a vector, and we saw something about vectors here. Where is it? Where do we need? Notice that I'm this is a heap variable. Okay, pointers on the heap. I don't know anything about the elements. Since they are on the heap, it doesn't matter how much space they are taking. So, does it make sense? So it would definitely not work with arrays, and it was only working because vector was using pointers. Actually, it would work with arrays too. Okay, maybe I explained it in a wrong way. This is the right thing, but this is something about polymorphism. The previous explanation was wrong, okay? The right explanation is the right explanation is because of the polymorphism. That means polymorphic. I'm using my pointer here, so thanks to polymorphism, it doesn't matter how much space A or B takes, okay? I can behave it as a pure virus object. So I'm just allocating space for the pointer, not the object itself. You can consider this like that. So it doesn't make a problem with the arrays or vectors. Bu oldu mu? Yani burada pointer'ın ne kadar yer tuttuğu önemli aslında. Tamamen polimorfizmden kaynaklanan bir durum. A'nın ya da B'nin ne kadar yer tuttuğu önemli değil. Ben vektörün içinde de array'in içinde de virüs tutuyorum. Bu sebepten ötürü, yani polimorfizm durumundan ötürü. Ama yani bunun daha güzel bir açıklamasını araştırıp da yapabilirim. Yani bu biraz çünkü benim tahminim oldu. Polimorfizmden kaynaklanması gerekiyor mantıkken. Ama daha böyle tatmin edici bir cevabı araştırıp verebilirim. Can be created, how much space will be allocated? Actually, the space is just the virus space because I'm allocating pointer for virus. But the thing that points is actually an A or a B object. But the space that I'm allocating inside the vector is just as the size of the virus. Okay. One last important example, and I'm finishing the class. Is there any question, by the way? Template, okay. This example. You do not have any question? Okay. Okay, yes, you can ask after the class. Okay, let's see this example. I think you got these things. By the way, the things that I'm explaining here are mostly the exam questions. Namely, the logic that you should get during the exam is this kind of things. Okay, the logic behind them is important. So let's see some. For example, this is a very good exam question. This example. Okay, let's see. It defines three things. By the way, parent is my base class. Child is derived class, inherited from parent. And I have parent P object, child C object, and a pointer to parent. Okay. Let's see parent P and child C. It calls print class, P.print class, and P.print virtual. Actually, it calls just these things. Just print class function of parent class and print virtual function of parent class. So it prints to the screen P and P. These two P, okay? Comes from here. And let's see C.print class, C.print virtual, C.print on function. I have two parent class function, one from the base class and the other from the C object itself. But it doesn't anything in front of this function. So I'm calling it C.print class. It will directly call this one, okay, not this one. So it prints C to the screen. and then it calls print virtual. Where is it? It calls this one. So it will print C again. And then it calls print on function. This function doesn't belong to parent. Parent doesn't have such a function, only child has. Okay, it automatically calls this one and prints C. So C, it will print it. Now let's see something different. I'm using a parent pointer Q and I'm assigning it to parent variable. Oh, okay, this is not also spatial. I'm calling again print class print virtual. This is the same thing with the here. So it prints P and P. Now the spatial thing comes. Pay attention to here. I'm assigning C, address of C to the parent pointer. This is child, this is parent. Now I'm calling print class function. I have two print class function, but which one will it call? This one and this one. It will call the first one actually, because Q is type of parent and print class function doesn't have a virtual keyword in front of it. So it will not call this one. It will call parents print class. So it will print to the screen P. Where is it? This 2P was coming from here. Okay, it will print to the screen P. Here it was printing C, but here it is printing P because this is type of parent. This is directly calling from the child object. But now I'm calling print virtual function. Will it again call the base class function? Do you think? No, because this time this has virtual keyword. Since it has virtual keyword, this time it will call the right print virtual function, namely this one. Again, I'm calling it from the parent operator, but this is not. This is actually not a parent object. This is actually a child object, and since it has a virtual keyword, it directly calls the child's print virtual function. So it prints to the screen C. Okay, and this last C comes from this line. Now I want to call the print on function, this one. And note that my parent class doesn't have such a function. If I call it like Q pointer, similar to them, Q pointer print of Q arrow print on function, it gives an error. You cannot call it in that way because it sees that Q as a parent and it cannot find any print on function inside the parent, so it gives an error. But you can dynamically cast it. So after the dynamic casting to child, this is not dangerous because you know that this was already a child object, so this is not harmful. So I'm safely casting it, and now I can call print on function, this one, and it prints the last C. Did you get it? This can be a good exam question. Virtual mixed difference one, polymorphism exists, right? I'm assuming. Virtual is something spatial to polymorphism, but polymorphism is not something spatial to virtual. Namely, virtual keyword is a subset of polymorphism, but polymorphism is not a subset of virtual keyword. Namely, forget about the virtual keyword. Just calling it from the parent pointer like here. Okay. Remove the print virtual functions. Just assume the print class functions. And when I call it like Q print class, it will always call this one. Okay, but I'm reaching C object from the parent pointer. This is just polymorphism. And I said that virtual is a feature of polymorphism. Namely, virtual is a subset of polymorphism. Yani virtual birazcık daha özellik katacak. When I use virtual, it also gives permission to call this one. Okay? The choice one. Did you get it? Okay. Now, actually, I'm finishing the class. Just a few reminder things. Templates are actually very easy. There's no something special about the templates. For example, you want to define a class, okay, like that, but you want to make it open. You want to make the variable and function returning values open. What do I mean with open? Actually, I mean that they can be char, they can be double, they can be integer, they can be an other class, for example. They can be anything. So I'm not specifying it here. Instead, I'm saying that this is a template class by giving this template keyword, template class T. And instead of T, it means that you can use anything you want. Like here, for example, when I want to call it with integer, I'm just writing inside these arrows int, okay? But you can give spatial definitions for some spatial types. For example, it says that other than char, you must use this one. But if you want to use this class with char keyword, then use this one. If it is not char keyword, for example, if it is integer, double, other class, then use this definition. But only for char, please use this definition. Okay, that is it. Templates, there's nothing special about templates. Also, I want to mention one thing too. Some of your friends asked at the beginning of the class, did you see these things? Virus, if, def, define, and at the end, handif. For example, you want to include this header file inside more than one CPP file. For example, in source file, in source 1 CPP, you want to use this header. Also in source 2 CPP, you want to use header, okay? Then, if you do not include these things, that means you are again defining this content in source. First, you are defining this content in source 1 CPP, and in source 2 CPP, you are again compiling, you are again running this content, and in source N, you are again compiling this content. So you are defining this thing more than once, and this gives an error. In order to prevent this error, you are using these definitions, okay? If def and define, and at the end, you have to use this one. If you use this, then compiler defines these content only once. This content only once. And in here, you can give any name, okay? Generally, conventionally, this becomes the name of the class, but you can give anything you want, actually. So, did you have any question? I will share these things. Friend keyword. Oh, I forgot. How you should compile and how you measure the memory leaks. These are already given in the PDF presentation. I will share these things. This friend is also important. Let me talk about it. Friend means I can use friend keyword with the classes and with the functions. And when I use friend keyword, for example, friend class A, this means that I'm saying to class B that, hey, class B, this is your friend. Class A is your friend. So since it is your friend, it can reach your private members. Okay? Similarly, if I'm using it with a function named func, I'm saying class B that, hey, class B, func is your friend, so it can reach your private members. So you'll see the definition of function. This function doesn't belong to B, actually, because it doesn't have B ... func. It doesn't have such a definition. Pay attention, please. So this is an outside function, okay? But this is friend, so it can reach private members. For example, integer num is a private member, so it can reach its member. Similarly, class A is a friend, so class A wants to reach B's private members. For example, it has an object B star B, and it can reach num member. Num member was private, but I can reach it inside my class A because it's friend. Okay, that's it. So do you have any question? I'm sorry for it takes 3 hours, but this is the best that I can do, actually. Do you have any question? Sorusu olanlar olabilir.
Hocam, can I ask again about the viruses?